Every year, humanity generates over 2 billion tons of trash. That's like every single person on Earth, tossing away 5 kilograms of waste every day. But here's the twist. What was once seen as a curse has now become a goldmine for an emerging industry. In places that once smelled of rot and danger, high-tech machines are now hunting treasure hidden in the chaos of waste. Robots with sharper vision than the human eye can now do in seconds what people struggled with for years. And this, believe it or not, is just the beginning. Stay with me until the end, because you'll hear how a teenager's bold idea has changed the fate of our oceans forever. The waste management industry is in the middle of a technological revolution, driven by artificial intelligence and robotics. In today's advanced recycling plants, robotic manipulators guided by sophisticated algorithms are redefining what efficiency looks like. Equipped with computer vision systems, these robots instantly recognize plastics, metals, glass, and paper. They sort faster than any human, making recycling cleaner, quicker, and far more profitable. Picture the scene. A conveyor belt carries a chaotic flood of waste: plastic bottles, crumpled cardboard, aluminum cans, milk cartons, shattered glass. To the human eye, it's just trash. For workers, it's grueling, dangerous work, but hanging above this torrent, like a mechanical predator, is the sorting robot. It doesn't look like a humanoid from a sci-fi movie. Instead, it's an industrial arm, sleek yet menacing, controlled by an invisible brain of artificial intelligence. Its eyes aren't mere cameras, they're multispectral sensors. These sensors can detect light reflections, analyze chemical signatures, and identify shapes in fractions of a second. Before being deployed, the AI was trained with millions of waste images, much like teaching a child by showing endless photos until recognition becomes second nature. Now this robot flawlessly identifies PET plastic bottles, HDPE canisters, paper, metals, and glass. The action unfolds in real time. The conveyor rushes forward. The AI scans, target locked, aluminum can. A signal is sent. The steel arm strikes with lightning speed, faster than the eye can follow. A suction cup grips the can, lifts it, and tosses it into the right container. Instantly, the AI spots a plastic bottle and commands the arm again. Some models achieve up to 100 picks per minute, over 1 every second, with 95% accuracy. Unlike humans, these robots never get tired, never lose focus, and never make mistakes. They can run non-stop, transforming trash into valuable raw material. But sorting is just the beginning. Once materials are separated, they still need to be broken down into usable form. This is where the rotary shredder takes over, a beast of the recycling world. On the outside, it looks like a steel box, but inside lies a spinning rotor lined with teeth of hardened steel. Feed it an old bumper, wooden pallet, or a mountain of plastic barrels, and the shredder devours it with a roar. Hard plastics snap, metal crumples, wood splinters. This raw destruction isn't chaos, it's precision. Shredding makes materials easier to transport, separate, and recycle. A pile of shredded plastic can be melted and reborn as pellets, ready for a new life. Yet not all waste remains on land. Some of it haunts our oceans in horrifying quantities. The Great Pacific Garbage Patch, a floating nightmare larger than some countries, has become one of the world's direst environmental crises. Many dismissed it as impossible to fix. But then came Boyan Slat, a Dutch teenager with a vision that would change everything. Instead of chasing plastic across the seas, his idea was to let the ocean deliver it itself. He founded the Ocean Cleanup, an ambitious project that deploys massive U-shaped floating barriers. These aren't just nets, they are engineered marvels. A floating boom on the surface stops plastic from passing, while a submerged skirt funnels trash down, letting marine life swim safely beneath. The system doesn't even need engines. It drifts with wind, waves, and currents, moving slightly faster than the plastic itself. Like a shepherd gathering a flock, it herds waste into its trap. The journey wasn't smooth. Early prototypes snapped under storms, and technical setbacks threatened the dream. But persistence paid off. Today these barriers successfully capture tons of ocean plastic, from abandoned fishing nets to microscopic fragments. Support ships collect the haul and deliver it to recycling facilities, closing the loop on ocean waste. What began as the dream of a teenager is now a global project, giving humanity a fighting chance to heal the seas. But Boyan and his team knew one truth: Cleaning the ocean without stopping the flow of trash is like bailing water from a sinking ship, so they went to the source, the world's most polluted rivers. The solution? The Interceptor, a solar-powered fully autonomous vessel resembling a futuristic catamaran. Anchored in rivers, it quietly collects plastic day and night, intercepting thousands of tons before they ever reach the ocean. And it does this without disrupting shipping routes, proving that efficiency and innovation can coexist. Every coin in your pocket has survived extremes during its creation that would destroy almost anything else. Think about it. Furnaces hot enough to melt glass, pressure strong enough to crush cars, yet these small, ancient-feeling discs endure. And despite living in an age of digital payments, coins remain oddly essential. They still feed parking meters, drop into vending machines for a cold Coke, and jingle in pockets across America. The strangest part? Some coins, like the penny, actually cost more to produce than their face value. The journey of a coin begins at the US Mint with massive metal coils, some stretching over 1,500 feet, the length of 4 football fields. Their different colors hint at the distinct metallic formulas destined for different coins. Workers carefully load these enormous coils onto turbines, which slowly unwind them and feed the sheets into a powerful pressing machine. It looks deceptively simple, but these coils can be stubborn, requiring a skilled human operator to guide them at the start. Once in motion, the machine roars to life, cutting out 14,000 blank discs, called planchettes, every single minute. The Mint compares it to a cookie cutter, stamping out coin after coin in rapid succession. Workers know the moment fresh blanks emerge, because the machine gives off a rhythmic sound as buckets fill with shiny metal circles. But the process also produces waste, heaps of jagged scraps of leftover metal, known as webbing. These twisted, oddly shaped remnants pile up like autumn leaves being raked into bins. They won't go to waste, though. Every bit will be shredded and recycled to make future coils. At this stage, the discs resemble coins, but aren't quite there. They're the right thickness, but not the final diameter, and they lack the durability and brilliance people expect. To get there, they must endure fire and water, an extreme transformation known as annealing. The annealing furnace is a beast. It heats the discs to a blistering 1,600 degrees Fahrenheit, hot enough to warp or melt most things. Yet the blanks emerge unscathed. How? The furnace is starved of oxygen, meaning the flames can be precisely controlled. Without oxygen, the discs don't tarnish, and they survive the fiery chamber looking almost unchanged. But the danger isn't over. If they were left at that heat, the blanks would fuse together into useless lumps. That's where the special water comes in. This isn't ordinary water, it's infused with citric acid and lubricants. The acid, derived from citrus fruits, plays a crucial role. It strips away dirt and grime, leaving the discs with that unmistakable fresh from the mint sheen. For pennies, which are mostly zinc-coated with a thin layer of copper, citric acid removes copper oxide without eating away the coin itself. The lubricants prevent the hot blanks from sticking together as they cool. Without this careful bath, the coins would be ruined before they ever reached your pocket. After their fire and water ordeal, the blanks are thoroughly washed. Here's where the Mint's two main facilities, Denver and Philadelphia, take slightly different approaches. In Denver, massive skip baskets scoop the blanks out of the water, lifting thousands at once and dumping them into the washing system. In Philadelphia, a giant rotating whirlway machine slowly turns, giving the blanks a gentler ride toward cleaning. The methods differ, but the goal is the same: restore the metal's luster with detergents and anti-tarnish agents. By the time they emerge, the discs are spotless, gleaming, and ready for the next critical step. Once dried, the blanks are prepared for the upsetting mill, a machine designed to form raised rims around the edges. This step doesn't just make the coins look finished, it strengthens them, protecting the design from wear and making them stack neatly. It's a small detail, but one that ensures coins can survive years, sometimes decades, of heavy use without losing their form. Remember that part where the blank coins weren't in their finished size yet? That's where the upsetting process comes in. The unfinished coins are sent into a groove that's slightly narrower than their current diameter. This forces the metal around the edge to rise just a little, forming a rim. But don't be fooled. This rim isn't just for decoration, it's the difference between a coin that survives its journey through the minting process and one that doesn't. Without it, the coin won't even make it to the finish line. Once the rims are formed, Mint workers take over, carefully inspecting each piece. Their job isn't just routine, it's critical. Every coin must meet strict size and quality standards, and the rim is one of the most important safeguards against counterfeiting. With counterfeit coins flooding markets and even entering the country through ports of entry, this step is the first line of defense. In 2020 alone, officials in Chicago seized a massive haul worth $1.64 million in counterfeit coins and cash. Without these meticulous inspections, counterfeiters would have an open invitation. If the blanks pass inspection, they move on. Some coins head directly to the next stage, while others go through an additional cleaning process called burnishing. This step is almost pampering. The coins are placed inside a drum with cleaning agents and small metal pellets to polish and smooth their surfaces. Afterward, they're even rinsed and hand-dried with towels, as if they were delicate treasures. But that gentle treatment is about to end. It's time for striking. The striking phase is where the transformation happens. The once blank planches are placed into powerful machines that stamp the iconic heads and tails designs onto both sides at once. And the force? Enormous. Depending on the denomination, regular circulating coins are struck under pressures ranging from 35 to 100 metric tons. For collectibles, the intensity ramps up even more. America the Beautiful silver coins, for example, face an incredible 540 metric tons of pressure. Proof coins like American Eagles aren't struck just once, they're pressed at least twice, ensuring flawless detail. And this isn't a slow process, it's a high-speed symphony of metal and force. Each machine can strike 750 coins every single minute. At the Philadelphia Mint alone, 63 presses run simultaneously, cranking out up to 47,250 coins per minute. Over in Denver, another 54 presses produce 40,500 coins a minute. Together, that's millions of coins being born every hour. But here's something fascinating. Those raised rims we saw earlier play a crucial role again. When the planches are struck, they're held snugly inside solid metal collars. Without those collars, the enormous pressure would cause the metal to spread out like a pancake, creating misshapen coins. Before collars were invented in 1828, coins were indeed wider and far less convenient to carry. Today, thanks to collars, coins are compact yet thick, allowing alloys like 8.33% nickel blended with copper to give dimes and quarters their signature durability. Finally, the coins roll off the conveyors in gleaming piles, ready for one last inspection. Quality control workers randomly check them to ensure every detail of the design is flawless. If a batch fails, those coins don't make it into circulation. Instead, they're sent to a machine called the waffler, which bends and distorts them into crumpled waffle-like shapes. These rejects are then recycled or sold off as curiosities. It's a reminder that not every coin earns the right to carry value. The coins that pass inspection are carefully counted, weighed, and packed into massive bags. These aren't your average bags either. When full, they're so heavy that only forklifts can move them. The forklift stacks them high onto shelves, where they wait until the Federal Reserve places an order. From there, the coins will eventually find their way into cash registers, piggy banks, and pockets across the country. But there's a twist. Pennies, America's most familiar coins, may not remain on those shelves forever. With debates over their future continuing, the humble penny's days could be numbered. So next time you hold one, consider it a piece of history still hanging on in a world that may soon move on without it.